Sir, where's the VLANs? Aren't there supposed to be VLANs? Put those back! That was me in a meeting with my networking team, and we had a guy from Cisco come in and start telling us about ACI, Cisco solution, their software-defined networking solution for the data center, and we were thinking about going that direction. And he drew our network diagram up there, and then converted it to ACI, and I was like, "What'd you do with our VLANs?" Cisco ACI, the application-centric infrastructure, kind of a mouthful. It's their SDN solution for the data center. Now we have talked about SDN and kind of the architecture. In the previous nugget, we talked about the underlay and the overlay and how we use VXLAN to make everything look really great and cool. But I felt like I'd be doing a disservice if I didn't talk a little bit about ACI and how the data center is being automated. Because odds are, as a network engineer, you're going to encounter data centers and data center infrastructures. And we'll start with the most common way we see data centers designed, the spine and leaf design. Let's take a look. So this right here is the preferred design of modern data centers, and really, if you're looking at doing an SDN architecture, this is really highly sought after. This is called a spine leaf architecture, also referred to as Claus. Claus is just the guy who thought of this. That's his name. I can't get out of my head Santa Claus giving us the gift of spine leaf. Thank you, Santa Claus. So with this design, we have two types of switches in our topology. We have these guys right here, which are our spines. And then these guys down here are our leaf switches. Now this design has been around for a while. It's not specifically for SDN. People have been using this in their data centers for a while. Why? Well, because it's simple. Notice a couple things here. First, our endpoints, which can be VMs, servers, containers, whatever's connecting to the network, they only connect to leaves. They will never ever connect to a spine. Also notice that each leaf is connected to every spine. Boom, boom, boom. And that every spine is connected to each leaf. Boom, 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 boom. The reason for that design is to keep the topology simple, and everything is only 3 hops away. Now, if you look at it compared to like a typical 3-tier architecture, your leaf kind of has your distribution and access layer combined, whereas your spine, think of that as your core. Now, what's great about this design is, first of all, if you need more ports, you just add another leaf switch, and you connect it up. Boom, boom, boom. You have more ports. If you need more bandwidth in your backplane and your core, you add another spine. Boop. And you connect it up. Boom, 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 boom. Now we're going to bring in some SDN. Let's bring in our SDN controller, our brain. There he is. Yeah, let me scoot you over here, bud. There you go. Welcome. Now in the ACI world, the SDN controller is called the APIC, the Application Policy Infrastructure Controller. And if you recall from our previous nugget, what we just did here, putting together all of our spines and our leaves and connecting them with layer 3 connections, all running some kind of routing protocol that'll make it all redundant, equal cost, beautiful. This is our physical topology, and that's going to be our underlay. The APIC over here, Mr. APIC, Mr. Brain, is going to be in charge of putting in the overlay, which will be whatever we want it to be. It's a logical virtual network on top of the underlay, on top of the physical network. Now let's get back to my example in the beginning where I talked about how I was like, wait, where'd the VLANs go? Why don't we have VLANs? This is how ACI does. I just bit my tongue. This is how ACI does things. And I wanted to talk about this because I think it's so cool and it was mind-boggling to me. In ACI, we're not talking VLANs, so blah, blah, blah. We're talking endpoint groups. So we'll take our endpoints, which will be VMs or containers or even just physical servers with one OS installed on the bare metal, and we'll put them in endpoint groups. So what we'll typically see in the data center is like a 3-tier application, like a web application. 3 tiers meaning you will have a group of servers that will be responsible for your databases, a group of servers responsible for your apps, where your apps will live, and then we'll have a group of servers that's responsible for your front end, your web front end. These will all be what's called an endpoint group because, you know, it's a group of endpoints. And we'll say, okay, I want the databases to be able to talk to the apps, and I want the apps to be able to talk to the web, so I'll be able to dictate how they communicate, if they can communicate, and what rules apply and all that logic. That's what we call policy in ACI. We define some policy. What's beautiful about this is I don't have to worry about VLANs. I just decide that, hey, this server is a database server. I'm going to put it in the database endpoint group, and I want him to be able to talk to the endpoint group apps. You see, that was my intent. I'm just saying I want these guys to talk to these guys. ACI more specifically Mr. APIC here, the controller, just makes it happen. He translates my intent to what should actually happen in the network. And it's crazy how this works because, I mean, these database servers, they could live anywhere in this topology, physically anyway. I could have a database server connected here, one over here, and one over here. As long as I assign them to that endpoint group, they're part of it, and ACI takes care of the rest. No talks of ether channel, VLANs, what ports they're connected to. You don't worry about that. Now that's a very, very, very oversimplified view of how ACI works. Of course, you can go a lot deeper, especially if you want to go down the data center track and learn about how all this works. Super fun, super exciting stuff. Now, as we talked about before, with a SDN controller, we have both southbound and northbound interfaces. With ACI, that southbound interface was called OpFlex. And then as far as the northbound interface, well, it could be a REST API that we interact with programmatically through our scripts or even other programs. It could be a beautiful GUI that we interact with. You want to see it real quick? I've got it right here. This is actually a part of Cisco DevNet. So if you want to access DNA Center or Cisco ACI, you can just go access a version of it and kind of play around with it. Now, you can't go crazy, but you can still sniff around and get your feel for it, practice some scripting. It's so cool. So I highly encourage you to go check out DevNet. developer.cisco.com. I'm just going to log in real quick and meander around. And similar to DNA Center, we have this beautiful GUI. We can just go in and configure our network with a few clicks. We give our intent to the controller, and the controller takes care of the rest. So that was a peek behind the curtain of what we do in our data centers for software-defined networking. We use ACI, the application-centric infrastructure, and we use the SDN controller, the APIC, the Application Policy Infrastructure Controller. Okay, got it. We saw how commonly when we design our physical topologies in the data center, our underlays, we use a leaf spine topology. The leaves being our distribution and access layer, and the spines being our core layer. And then the APIC has the overlay on top, and we kind of do away with the thoughts of, well, what VLAN is this? Do we need ether channels here? I need to put an access list here. No, we don't think about that. We say, I want these people to talk to these people. My intent is for this and this to happen. And again, that just scratches the surface. Woo! I hope this has been informative for you, and I'd like to thank you for viewing.